for listening to us and watching us and providing questions. I'm trying to drive the conversation so we answer to some of them in real time. Let's talk about the nickel to Aaron's surprise. There was some observation with the VLT, the Very Large
Yeah.
Telescope of ISO, that shows some unusual high nickel to iron ratio. So what's that? Why is that such a big deal?
Yeah. So uh, basically, they've released data from several epochs of this comet's orbit. So as it's getting closer to the sun, they've reported this nickel to iron ratio, and it's been changing. But basically, at first, this nickel iron ratio was very, very high. Basically, we're seeing nickel, but we're not seeing iron.
Mhm.
And That's a little bit weird because we expect to see iron when we see nickel in our own solar system. Uh, but as this comet is getting hotter, is closer to perihelion, uh, that ratio is changing. It's still high, I believe, but it is getting lower. So the iron is showing up. And I think it's weird. In general, we start to ask this question, why are we seeing this in comets that seem to be too cold to be sublimating rocks or metals? Why are we seeing metals in the coma? That seems strange. It makes you think, oh, it's a special metal, must be alien spaceship. But actually, we do see this in other comets too. We see this nickel and iron. The nickel to iron ratio in other comets is higher typically than what they have found for 3I, but we do see it. And there's theories about how this could happen. And it's this idea that there's a parent body of this iron and nickel that can sublimate at very low temperatures. It's this kind of organometallic
Mhm.
carbonyl, something like that, um, where it's attached to carbon. And then that breaks down very quickly when it sublimates, and then you see the iron and the nickel. So it was a little strange that we saw so little nickel early on. Um, but the fact that we are seeing nickel and iron is good for this hypothesis about these organic metallic materials.
I love what you're saying right now. Goes exactly where I'm going with this video. I've been binge watching 3i Atlas for the freaking last 5 months right now, since it started back in June, and asking a lot of questions about astrophysics. But I don't have a physicist in front of me. I don't have a professor easily accessible for me to waste my mind and my time and their time. I've been asking AI, primarily Copilot, for the general stuff and some of the better constructed narratives from ChatGPT. I used a little bit of Grok, but I stopped because I didn't like the source for a moment. I was like, I'm gonna wait a little bit before I get to that. That's my stack of printouts right there. See that? So I've been drawing hypotheticals with this to the point that it feels obsessive, right? So we're saying that 3i Atlas is a comet. And we're saying that it has chemical outgassing, but isn't a water outgassing like standard comets. So it's a comet, but a Q class, like a chemical class comet, not a H class, which would be hydrogen or water outgassing comet. But it has more characteristics like a meteorite, right? If you look it up, yeah. If you ask ChatGPT the questions, now the one thing that I have been asking is the origins. Why did it have so much nickel at the beginning? Why is it? They're not saying right now. We'll see if he says it. If the nickel now variance to iron is actually balanced out, like how we see it happen in our solar system, or the comets, meteors, and asteroids that happen within our Oort cloud, right? Now, there's three measurements. Like 3I Atlas is stuck within our Milky Way. Okay? It's not, what do they call it? Abby Loeb just spoke with somebody today, and he explained this, that it's based on the velocity. It's stuck within our Milky Way. That's how it can get that speed. So we're good. We're good on that. That's how fast it can go. That's the maximum, right? Give or take. It came from Sagittarius. That's the direction that we look at. If you look at Sagittarius, we look at what's happened over there. We got the wow signal. We also got the crop circle response from our Arecibo that supposedly came from that area too. I'm not sure about it, but that's what I'm deducing off some of the information. And now we have 3I Atlas. We got 3 bodies. We also have occurring over there 3 supernova eruptions. I asked about supernovas because the chemical composition requires high temperature for nickel to be separated from the iron, and there has to have a lot of carbon, and the only thing that could be producing that would be most likely a star, or a core from a planet. You see what I'm thinking? You see what I'm going at? A supernova will break apart and it will turn everything into dust. That entire star blowing up will become dust. It can't make something as big as what 3I Atlas is said to be, like 32 billion tons, something like that, like the size of Manhattan. What is the range of this? It was 20 kilometers and it was 12 kilometers. So it's like 5 miles big, or it's 12 miles big. We're not sure because of what how we're looking at what you're looking at. She explains it here pretty well. She explains a lot better. Why is it that the regular scientific outlook on this is that it is a comet, and why we've gotten so many misreadings. Lord and behold, this isn't the only thing we've looked at. We've looked at thousands of comets, asteroids, and meteors, and drawn our conclusion on what are the patterns of looking at them. We've created this template of the time frame that we're going to spend observing to draw our conclusions, to draw the information, and that has been enough. But yet for 3I Atlas, they're now saying, yeah, it's only the third body, so we really don't have many examples. But you already have constructed a format for observation for these bodies. When you're fitting it into this format, it shows large amounts of anomalies. So we have to rewrite and recategorize what an interstellar body is, as a comet, as a meteor, as an asteroid, right? We have to write something new altogether. But we can't corral interstellar bodies the same way we corralled our solar system bodies, our solar comets and asteroids and meteors. Okay. Everything within inside the Oort cloud comes in from the Oort cloud. We know it. We know our backyard. Do we know our neighborhood well enough? Right? What if this 3-eye atlas isn't not only from a core of a planet or the center of a planet, the reason why it has a high nickel and it has these nickel formations, or from a broken star, or from a galaxies colliding or something in that nature? What if this is more serious than that? What if this is actually is a spaceship, right? Well, there's the greatest level of threat. Do we have an invading species finally reaching us after thousands of years? A colony that finally relocates because they've gone on the venture of being colonizers. Might as well be avoiding us. We're a pretty loud planet. When it comes to our radio signature and our light signatures out into outer space, we're pretty loud. We're the obnoxious neighborhood. We probably are the hood itself. With inside the Milky Way, we're considered the hood. Right? We're always fighting. We're always trying to kill each other. We're always arguing about simple planetary resources when there is so much of vast. Because everybody wants to pocket into their money backwards, right? A little bit more, billions of dollars that we consider valuable. I mean, don't even look at the diamond industry, what they do, right? Because we assign values that are unnecessary to resources that are abundant enough. And we constrain our human evolution to be able to adapt and assimilate other technologies and other resources when it comes to energy management and technology progress in a planetary scale. Abby Lowe said in the interview with Joe Rogan, which is something that I had said on the Stephen Bird's podcast. Sherry commented and it said, "Too bad that there's some interstellar bodies coming our way, and some species from another universe are coming over here to colonize the planets and resources that are in our solar system." And Avi Loeb repeated the same thing. It doesn't make me smart. I was making a joke, and he's making also an observation. The way that this comet is entering, asteroid, meteor, it has it all. Okay, it is definitely coming in at an angle that would be appropriate for any probe to come in. Any observation, it is the most luckiest comet ever. Okay, it's going by 3 of our planets. Looking for a new home, looking for real estate, or just a comet passing by, which is my vote that it is a celestial body, but it merits a separate classification altogether. Now we can lose our hyper focus on one comet and we can expand ourselves to looking at the total of 17 comet bodies that are currently crossing through our solar system right now. And we can seriously look at the 2,000 asteroid bodies that are also flying around us if we're really looking for a danger signal. Also, I'm not making a book, but in my conversation with AI, I decided to look at what would be the best solution for us to be more successful at managing our solar system. And I went into writing a fiction, and I created the perfect satellite. I asked for it to follow what we've done already with 3i Atlas, and let's construct an observation method that can be repeated and multiplied. First, it gave me land observation into outer space, like the Chile observatory and such methods. But I said I wanted a satellite. I want to be able to launch a satellite that is duplicable, that can form a space grid to be able to watch the north, the south, the east, the west, every single angle from Earth that we can possibly get. At least 6, but then another 6 to be launched. We can send those satellites or probes, right, into nearly every single planet within our solar system and have it be a satellite around the planet, or 2 of them be opposite size satellites around the planet, or 4 of them, and even their polar sides. We can send enough to be able to watch everything around it. So that way, if an interstellar body is coming, we can utilize those tools to take a look at who's coming in our neighborhood. Making a surveillance system around our universe seems difficult, but actually plausible according to AI. That's half of it, actually. The cost in US dollars without solar panels, because for some reason that's very expensive, is $25 million. Guess how much it cost China to do the same thing? Probably really ridiculous low. Yep, exactly. $3 million. Can China spare the money and build a dozen satellites that have the observation capability to be into one satellite, be sent out of space to be able to look? High resolution cameras, infrared cameras, thermal cameras, chemical composition, radio telescopes, whatever it is, and be able to transmit those signals over here, and a satellite to have a nuclear battery or something to be able to maneuver it and control it, to shift it, to have it point at different objects that are going through outer space. Right? Yeah, we can. Can we? Definitely we can. If we quit overpricing the government, it would be fair to have a global consensus of costs of manufacturing. The cost of living is too high. So if you want it, you got to pay for it, right? That's the source of capitalism. Communism operates like that. 3.5 million without the solar panels, barely with it, actually with the solar panels, it's like 5 million, give or take, for China constructing. For us, $50 million with the solar panels. I'm kind of frustrated with that because I feel like we're stumped. If the scientific community currently is saying that, oh, we haven't observed it long enough to know why, what is stopping America from observing it more? To just stare at it down for the entire time that it's still remaining in our solar system. What is stopping us? Politics? Declaring who's going to have the right to speak or what information is going to be released to the public? It's changing, paradoxically, astrophysics history on what we do to observe these celestial bodies. You could see it from Earth if you buy a Dobsonian telescope, anywhere from a 4.5 to a 12-inch telescope that is available for the regular public for under $2,000. Can't look at it. Okay? That's it for me now. If you want more, like, share, subscribe.